So, hello everyone. Today we are going to solve the container with most water problem. You are given an integer array height of length n. There are n vertices, n vertical lines drawn such that two endpoints of the ith line I, 0 and I, height of I. So basically a vertical bar is there, or you can say vertical wall is there. You have to find two lines such that it form a container and that particular container have the most water. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice, you may not slant the container. Slant means basically you just tilt or something. So basically this particular container is cannot be moved, right? So if you can't move, you can't slant. So the most basic way we can think is take all possible pair of ij and calculate the maximum water you can store. So the maximum water which we can store in any container will be the width and the height, the multiplication of height and width. Width can be found by j minus I plus 1, and the height, or I think we can simply do j minus I, it will give us width, and the height will be minimum of height of I and height of j. Right, since if the maximum water will be at the height of the minimum of j and I, right? Height of I and height of j. So talking about the constraint, the particular value of n is 10 raised to 5 and height of I can go up to 10 raised to 4. So we can see, since n goes up to 10 raised to 5, we cannot simulate our nested loop idea or 2 loop I and j, right? So we have to optimize it, and for optimization we can think of two-pointer approach, right? So in two-pointer, what we are going to do is we will maintain a left pointer and a right pointer, right? The width between left and right will be simply r minus l, right? And the height is minimum of height of r and height of l. So the area you are going to get is width into minimum of left height and right height. So, and since we have to maximize container, what you will do? You have two options. The value which is higher, you move that, or the value, the index which is pointing to the lower or the smaller height, you move it, right? It can be any of this, left or right. So what you are going to do is, since we have to maximize, we try to get maximum bar, right? So what we are going to do is, whatever is maximum, we don't touch it. whoever is minimum, we move it. If left pointer is the lower one, so we move L by 1, L plus plus. If right pointer is pointing to the lower boundary, we try to move it one step ahead, r minus minus basically. So let's go into code first. As I told, we are going to take two pointer L and R, right? So L is pointing to 0 and R is pointing to the last index, which is n minus 1 or height dot size minus 1. So I am taking a variable MW, basically maximum water. Initially it is 0. Let me do. This is basic template of two pointer. If L is then R, while L is then R, do the particular thing you are going to do. So as I told, we are going to calculate the width by this particular R minus L, and as I told, the height will be minimum of height of L, height of R, and we going to store max water. So MW is maximum of the answer we are currently having, comma this particular value, width into height, right? So now, as I told, since we have to maximize our answer, we try to move the minimum one, since there may be a possibility after moving by 1 I get the higher bar. So when I get higher bar, it will give me a bigger value. Let's suppose take a case, I am moving the higher bar, right? Let's suppose after moving my higher bar, I got even higher bar. Let's suppose I have some value x. Now after moving I got x plus 1. But since we are taking the minimum of 2, the height will still be same as that particular pointer which we have not moved. So for this particular case, we are trying to move that lower pointer, right? So this is the solution of this particular problem. So let's talk about time complexity. This is simple two pointer approach. We are iterating over once only, so it is order of n. We are not storing any extras, we are not taking any extra space, so it is order of 1. So yes, this is it. And as you can see, I have already submitted this particular problem, right? And you can access the code from github.com, my GitHub ID. If you don't know, GitHub and this particular repo, you can get, right? So this is it for today. Thank you everyone.